All right. Good morning, everybody. Welcome back. I'm excited to be able to see everybody. I know that the first people watching this are going to be Group A, Group B that'll be at home, and then Group A, if you are having questions from class, hopefully you're watching this video as well. But one of the things I want to do today is just kind of start us off. As you'll notice, we're going in 5.3. So just talk about what this unit is going to be about. This unit, Unit 5, as we start the second semester, is all about systems of equations. And what I mean by a system is it has two or more equations. So a system, we usually have this like curly bracket, right? And then in that you'll see two equations. So maybe y equals x plus 4 and y equals, I don't know, negative 2x plus 3, something like that. So that's a system of equations. It's got two equations. It's called a system. And basically, what we want to do is, what we learned in the first semester is that we can graph this, right? We can graph it. We can solve for x if we know y, and vice versa, right? So this unit, we are putting both of them together, and we're going to say, what are the solutions to a graph that would have both of these equations on it, or to a system with these two equations. Now, in order to find out what the solutions are, first of all, you have to know and understand that a solution is a set of values. So it's like, what's the x value and the y value that satisfies both equations, okay? So what I mean by that is, if I plug in a 1, is it going to give me a specific number? So if I plug in 1, negative 2 times 1 would give me negative 2. Negative 2 plus 3 is 1. So this will also be 1. So 1, 1 would satisfy this bottom equation. Okay, well, if I plug it in up here, 1 and 1, 1 plus 4 is 5. 5 does not equal 1. So this would not satisfy both. This would not be a solution that satisfies both equations. Okay, so we're going to look at some examples here in just a moment, just like that. So a solution makes all equations in the system true. All right, and on a graph, a solution is where the lines intersect. Now that's important, and I'm going to jump around here a little bit, because you can solve a system of equation in 3 different ways. All right, and it's important to understand these 3 ways. The one that we're going to talk about today is called substitution, where you substitute for a variable. Okay, and then the second way is elimination, which we'll talk about, I can't remember if it's tomorrow or Wednesday, where you eliminate a variable. Okay, and then the last way is graphing, which we just said is where it intersects. So you graph and look for intersection. Okay, so again, this is important because you need to be able to figure out, like in scenarios where maybe you're trying to sell hot dogs and hamburgers, and then somebody else is trying to sell something at their concession stand. So you want to know, like, how many customers if you have 2 businesses. So there are real-world applications to this, and we'll get to those as we continue on in this unit. All right, so let's come back up. Let's look at some examples here. Determine if the following are solutions to the given system. So again, if it is a solution, if negative 2 comma 4 is a solution, then when I take these numbers and plug them in for each of these equations, this is a system, then it will be a true statement for both. All right, so let's look at the first one. So y is 4 and x is negative 2. All right, so we're plugging into this first equation. So 4 equals 6 minus 2, and 6 minus 2, of course, is also 4. So 4 equals 4, that is a true statement. That checks out. Okay, so now let's check it out with the other equation. So 4 equals negative 1/2 times negative 2 plus 3. Okay, so again, y is 4, right? Y is 4, and x was negative 2. And now use this equation to plug it in. Okay, so 4 equals, a half of 2 is 1, and 2 negatives make a positive, so this is 1 plus 3. So 4 equals 4. This also checks out, so yes, this is a solution. Okay. All right, so we're going to try with this second example. So x plus 4 and negative 2x plus 1, those are the two equations. 2 comma 6 is my x and my y. So I'm going to plug it in up here. Y is 6, x is 2. Okay, 6 equals 2 plus 4 is 6. So the first one checks out. So that one's good. Okay, and then let's see, 6 equals negative 2 times 2 plus 1. So now we're checking out this equation. Okay, 6 equals negative 4 plus 1. 6 equals negative 3. This is wrong, so this is not a solution. Okay, so as you recall, we've done this before in earlier units in the first semester. If it was a solution, it only had to satisfy that specific equation. But in a system, it has to satisfy both equations. All right? All right, so what we're going to do today is, again, we're going to go through one of the methods. This is called, and then you'll have an exit ticket. This is called solving using substitution. There are different examples we will use this with. The first one is where y is isolated in both equations. So if you look, okay, you have a y by itself in both equations. So when that happens, when we substitute, what we're going to do is basically, since this is equal to y and this is equal to y, I'm going to substitute the 2x and I'm going to put it right here where this y is. So I'm substituting a variable. Okay, so as you can see, now I've written them equal to each other. We're going to solve for x. What's nice about this is there's only one variable to solve for. That's really the only way that you can solve equations at this point, is to get one variable. Okay, so this is x equals 4. All right, so that's our x value. Now, take this top one, because it looks like it's the easiest one to plug in for, but you can plug in for either one. Remember, a solution is where we want both an x and a y value. So y equals 2 times x, which is our 4 that was down here. So y equals 8. So our solution is 4 comma 8. All right, so again, when a variable is isolated on the side by itself, it makes the substitution process very simple. Take the right side, or whatever's not isolated, and plug it in. So 3x plus 5 equals 2x plus 8, because they're both equal to y, right? So thinking about substitution-wise, this is y, this is y. These are both equal to that. Okay, so y equals y, so that means, right, that would make sense. All right, so now we're going to solve for x, though. Eight, and then subtract 5 from both sides. X is 3. Perfect. Okay, so I have my x value. Now, take that and plug it into either one of these. So since they both have, you know, some things being multiplied and added, I'm just going to pick the top one, but you could do the bottom one as well. Okay, my x value was 3, add 5. 9 plus 5, which is 14. So my solution that would satisfy both equations is 3 comma 14. Okay. If you're not sure if you got the right answer, what could you do to check your work? Well, you could take this number, or this ordered pair, this solution, and you could plug it back into both of these equations and make sure that you get a true statement, right? Just like we did up here. Okay, plug it in, see if you get a true statement, right? Okay, so let's go through some more examples. What happens where y, or where a variable, is not by itself in both equations? Notice the second equation, there's no variable by itself. That's okay. Again, this method is called substitution. So since this top equation still has y by itself, that tells me y equals x minus 1. So in the second equation, I'm going to replace the y with this x minus 1. So instead of y, I'm going to replace it with this x minus 1. And then I'm going to continue filling it out. So look, 2x minus 3y equals negative 1. 2x minus 3y equals negative 1. Okay, so you're replacing it. Now there's only one variable left over, so we are going to solve it. Okay, I'm going to distribute the negative 3. So it gives me negative 3x. Negative 3 times a negative 1 gives me a positive 3. I'm going to combine like terms on the same side. So 2x and negative 3x are on the same side. That gives me a negative 1x. I subtract 3 from both sides. Okay, now I have a negative x, so I need to divide by a negative 1. So that gives me x equals 4. All right? Okay, so now let's take that and plug it back in. So we have y equals x is 4 minus 1. Y equals 3. Okay, so our ordered pair, our solution, 4, 3. All right, example 4, same thing. Only one has an isolated variable. So we're going to take this and plug it in. So 2x minus y equals negative 8. Don't forget your parentheses because notice the negative out front. That means I have to distribute that negative. So 2x minus 3x minus 5 equals negative 8. Negative x minus 5 equals negative 8. Add 5. Negative x equals negative 3. Divide by negative 1. And x equals positive 3. Okay? Take the 3, plug it back in. Plus 5, so y is 14. Okay, so this would be 3, 14. All right. Systems where no variable is isolated. All right, this one's kind of a pain in the butt because as you look at these equations, look, y is not by itself. It's got this 4x over here, 2x plus 3y. It's not by itself. So in a problem like this, it's probably easier to use elimination method. But for today, we're only working with substitution. So what we're going to do is we're going to have to take one of these equations, and isolate for a variable. So as you can see, y has a coefficient of 1, so that's going to be the easiest one to solve for. So I'm going to take that one off to the side, and I'm going to solve for y. Okay, I see all this stuff that we've done in previous units is coming back around. All right, cool. So now y is by itself. So now I'm going to take 4x plus 2, and I'm going to plug it in for the y on the other equation. All right, and we're going to simplify it. Distribute the 3. Okay, 2x and 12x are on the same side, so that gives me 14x. Subtract 6 from both sides. Divide by 14. So x is 0. 0 divided by 14 is 0. Okay, so now I'm going to plug it back in for x. And you can use this equation is fine. All we did was rearrange it, so it's still the same equation as before, just rearranged. Okay, so y equals 0 plus 2, so y is 2. So our solution here would be 0, 2. Okay, example 6, same idea. Here's my singular y, so I'm going to solve for y. Negative 5x plus y equals negative 2. Add 5x to both sides. That gives me y equals 5x minus 2. Okay, I'm going to take this, plug it in for the other one. Okay, negative 3x plus 30x, when you distribute, minus 12 equals negative 12. Okay, negative 3 and positive 30 gives me 27. Add 12 to both sides. A negative and a positive cancel each other out. This gives me a 0. Divide by 27. X is still 0. 0 divided by 27 is still 0. Okay, and then plug it back in. So, plugging in 0 for x. Let's see, negative 5 times 0 gives me 0. Okay, y equals a negative 2. So my coordinate point, 0, negative 2. All right. Last case, determine the solution to the following systems. Okay, so notice that these are isolated. These are special cases, and you'll see why when we get to the end. So since, again, the variable is isolated, we're just going to set them equal to each other. Since the same variable is isolated. Okay, subtract 2x from both sides. Okay, it gives me 3 equals negative 5 because it cancels out. Well, that doesn't make any sense, right? 3 does not equal negative 5. So when that happens, when you get down to the end and the left side does not equal the right side and you have no variable to solve for, this means there are no solutions to that system. It means that you would have two lines that would never touch. Okay, two lines that never touch. Which means graphically, what would they look like? They never touch. They are parallel. Okay. All right. Example 3. We've got a y that's isolated. Okay, this one's not. So we're still gonna plug it in. So 2x, so 2 times 2x plus 1 equals 4x plus 2. When I distribute the 2 to both sides. Okay, so now look at this one. This one, the left side is equal to the right side, and we haven't even done anything right yet, right? Okay, so what that means is that there are infinite solutions. It means that any number that you plug in would be a solution. And the reason for that is because 4x plus 2 looks like this. Actually, probably more like this. Okay? But guess what? This is also 4x plus 2. So this would be a line on top of itself. So this is infinite solutions. All right? So if you get down to the bottom and the left side does not equal to the right side, that's no solutions. If you get towards the bottom and you have the left side is exactly equal to the right side, that would be infinite solutions. Okay? And there's still a variable involved. Okay. So at this point, I want you guys to go ahead and try this exit ticket. Send me a Canvas message if you have any questions. Again, what property you're using today or what skill you're using today is called substitution method. You're solving systems using substitution. Let me know if you have any questions. I'll see you guys in class.